Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, we have discussed about mean value of a random variable with binomial distribution. So now here in this video, we are going to discuss about mean square value of a binomial distributed random variable. So we know that the second moment of a random variable is given by expectation of x square. So this expectation of x square is also written as m2, that is second moment, which is equal sigma I is equal to 1 to n xi square into p of xi. So this is the equation of the second moment of the random variable for discrete case. So now here expectation of x square is equal sigma x is equal to 0 to n x square into p of x. So p of x is equal to ncx into p power x q power n minus x for x is equal to 0 to n minus 1. So p of x is equal to ncx into p power x q power n minus x is the binomial distribution expression. So now here on RHS side, substitute x is equal to 0. The first term in the summation is 0. The first term in the summation is 0 and the remaining values of x, expectation of x square is equal, and after substituting x is equal to 0, the remaining values of x is equal to 1 to n. Therefore expectation of x square is equal sigma x is equal to 1 to n x square into ncx into p power x q power n minus x. Similarly, you are also simplifying the RHS term. So first applying the ncx expansion. So now here x square, in this x square term by adding and subtracting by x, we have sigma x is equal to 1 to n x square. By adding and subtracting by x, we have minus x plus x into ncx p power x into q power n minus x. So this x square minus x plus x is written as x square minus x into ncx p power x q power n minus x plus x into ncx p power x into q power n minus x. So multiplying this term within the bracket term, we have x square minus x into this term and x into this term, and applying the summation into each term, we have this is the resultant expression. So now here this x square minus x is written as x into x minus 1. Take the common x. Therefore, sigma x is equal to 1 to n x into x minus 1 into ncx into p power x q power n minus x plus sigma x is equal to 1 to n x into ncx p power x into q power n minus x. Now here on RHS side, the second term. On RHS side, the second term. This is the second term. So the second term is the mean value of the binomial random variable. So the mean value of the binomial random variable already explained in my previous video. So that mean value of the random variable is n into p. N into p. So now simplifying the second term in the same process. What is that same process? Mean value of the random variable. Mean value of the random variable ఎలా అయితే సింప్లిఫై చేసామో here also simplifying this first term. So now here in the first term, first substitute x is equal to 1. Substituting x is equal to 1, 1 minus 1. 1 minus 1, 0. 0 into something, 0. So substituting x is equal to 1. The first term is 0. The first term for x is equal to 1, that is x into x minus 1 is equal to 0. And the second term is mean value of the random variable. So therefore, so substituting x is equal to 1 in the first term, the first term is 0 and the remaining values of the x of the first term is x is equal to 2n. So therefore, expectation of x square is equal sigma x is equal to 2n x into x minus 1 into ncx p power x q power n minus x plus, and the second term is the mean value of the binomial random variable. That value is n into p. Now applying the ncx expression. And what is the expression of the ncx? n factorial by x factorial into n minus x factorial. So, and after that, expanding n factorial n into n minus 1 into n minus 2 factorial, expand x factorial x into x minus 1 into x minus 2 factorial, and n minus x in that term by adding and subtracting by 2 we have n minus x minus 2 plus 2 factorial, and this p power x is written as p square into p power x minus 2. So in this q power by adding and subtracting by 2 we have q power n minus x minus 2 plus 2 plus second term is np. So now here x into x minus 1 is cancelled numerator and denominator, and the remaining term is sigma x is equal to n into n minus 1 into p square n into n minus 1 into p square into n minus 2 factorial by x minus 2 factorial into, so this term is written as n minus 2 minus of x minus 2 factorial into p power x minus 2 q power, that q power term is arranged as q power n minus 2 minus of x minus 2 plus np. So using this expression n minus 2 factorial by x minus 2 factorial into n minus 2 minus of x minus 2 factorial is written as n minus 2c x minus 2. So therefore n into n minus 1 p square is written before summation into sigma x is equal to n. So is the this term is written as expansion of n minus 2 c x minus 2 p power x minus 2 plus q power n minus 2 minus of x minus 2 plus np. So using binomial expansion, this within the bracket term is the p plus q whole to the power of n minus 2. So therefore, expectation of x square is equal n into n minus 1 into p square, that within the bracket term is p plus q whole to the power of n minus 2 plus np. But p plus q is equal to 1. Substitute p plus q is equal to 1. 1 power n minus 2 is 1. So therefore, n into n minus 1 into p square, 1 power n minus 2 plus np. So 1 power n minus 2 is 1. So therefore, n into n minus 1 into p square plus np. Multiplying np square within the bracket term, we have n square p square minus np square plus np. And the second term and third term take the common np. Therefore, n square p square plus np into take the common np second term third term, np into 1 minus p. But from this equation, 1 minus p is equal to q. So therefore, expectation of x square is equal n square p square plus npq. So this is the final expression, final value of the mean square value of a binomial distributed random variable.